G'day guys, welcome back to Marky Mark's 372 build. We're going to kick it off where we left off, and that's with the Sump. This one here, basically, last time we talked, it was thinking about cutting and shutting the Sump, cutting this out, blocking this one up, turning the dipstick provision from left to right hand side. Yeah, I did go out and have a look to see what was on the market, and did find a Sump that was under $300. So this one here is from Aeroflow. This is the Sump that I picked up for under 300 bucks. I thought, you know, let's get in there and do the changes I need to the old Sump, but by the end of it, it would have ended up being like a Franken Sump deal. Yeah, just two cut and shut. So he picked this one up from a place here locally in Adelaide. And I'm still going to have to do a bit of cutting and shutting to make it fit, but there it is. So it's got a bit of a wing sump on it. I'm going to have to cut out a section here for the starter motor. The starter motor on the Ultima is a little bit different setup than standard Chevy starters. Standard Chevy starters sort of bolt up onto the block, where this starter motor basically bolts into the bell housing adapter. And then we're going to have to cut the back section out here for it to fit the cross brace, or cross member should I say, in the vehicle. Both the Sumps lined up here. We have the old one, the engine, and the new one. Looks like they line up pretty good across the top. Just line them up here in the edge of the table. So, oh, that looks not too bad. A little bit, this pan could be a little bit deeper marginally, a couple of millimeters, but I don't think that's going to worry the pickup on the oil. And then so we're going to need to make up some drain tubes for the turbos, or connectors into the fittings into the Sump. So we'll mark the line about the same depth as that. From memory, I believe this is got a little bit of gap there anyway between the cross member and the Ultima. Okay, let's try with a new paint marker. Alright, close enough for the bush. So you've got to come down about 27 mil off the back here. We'll mark that one up. And then here we're about 12 mil down. Mark about 12 mil down, good enough for the bush. And on the other side, One piece off. We'll go ahead and clean all the edges up, and we'll cut a bit of steel, bend it up, and we'll tack that in with a TIG. And then I've got to cut the relief from the top, this section here, for the starter motor. Got the edges cleaned up. Just use a hand file and a deburring tool around the edges. Now get a bit of cardboard out and tape measure and measure up, cut a bit of steel, get it on the folder and bend her up. We've got that done, cut out, got the line across here now, so we'll get that over the bender. Well, we've got our first bit of the cut and shut done. Sump here, the back section of it cut out. I'm just going to, I've washed it up with soapy water, blowed it down with some air. I'm just going to set it on the engine here and make sure the plate misses the back of the oil pump here. Just drop the sump on the top. The first time I've actually put the sump on. I don't even know if it's going to fit anyway, being a cheap. Oh, it's a bit tight. Yeah, it's a bit tight, alright. So it looks like we've got plenty of room there. In, yeah, we've probably got, I don't know, 3/8 of an inch, I guess, 7/16 of an inch, 10-11 mil. Righto, let's tack that in place and then we'll check it again, weld it up, and then I think we'll cut the groove out for the starter motor, the recess. See if we can't get this plate tigged up in position. Just get set up here. Not too bad. Not quite close enough together. Need a little help. So the idea is we'll get a few more tacks and a few more spots pretty close to each other. That way, or when we go to do a complete run, hopefully that'll stop a lot of distortion from the metal heating up and expanding. Yep, if we start welding at one end, say, you know, it'll end up, the steel will end up, because of the heat, will expand, and then we could end up with a bit of a gap or some warpage. So yeah, we'll just tack it in quite a few spots, and then we'll do a bit of a run, stop, and do a bit of run somewhere else, stop, and sort of just blend it in until we've got the whole lot tigged up. So I've had a bit of a closer look at my weld here, and wow, it's not pretty. I had to go over it a little bit, didn't quite have enough heat in it. I think I might have left a few pinholes, so I just went over it again. Like I said, it's definitely not pretty, but it should not leak, and yeah, bit of jam on there, yeah, you won't even know. Oh, that's true. Right, gotta get out of 26. Oh, this is painful. Oh. Beauty, that'll do it. Give her a bit of a clean up. Righto. So it's a good thing we got the bung welded in. It's okay. Finish the threads off with a 1/2 inch MPT plug tap. Just a bit of, if anything, a little bit of Teflon sealant or Teflon tape, and good to go. Nice and large, so we get lots of oil flow. Now we've got to install the turbo drains, same as some of the original ones here. So that's a -10 JIC fitting. Got a couple of new fittings here. Got these from PMD. Jared name on, young Ethan helped me out with that one. So I'll put that in the lathe, drill the hole right through, and then we'll bang a hole in this sump here, and then we'll TIG that in. That one and another one for the other side, and that's it. Clean the sump up, we'll get it down, we'll get it into the bead blaster, and then we'll give it some paint. Got the holes drilled out in the sump, both sides. Went ahead and put the fittings into the lathe, drilled a hole right through them, then took the back off a little bit there, so just a little lip so it recesses in the hole. Just makes it a bit easier to weld it up, keep in position. TIG that in, and then cut a section out the back for the starter motor, weld that up, and then we can get it cleaned up and ready for assembling on the engine. Okay, so we finished welding the sump. Got the recess in the top for the starter motor. There's a bolt that gets sort of put in there on the adapter plate, so that needs to be cut out. That's done, welded in. We've got the drains for the turbos in. We've got the bit for the rear subframe to miss that on the sump, and we've got the drain plug in it. So we're just about done here with the sump. We'll just fill it up with water now, and we'll check our welds for any leaks, repair as necessary, then we'll get it down to the bead blaster and bead blast the inside and clean the sump up and get it ready for paint. So we've let a bucket of water in. Just going to go around all the weld points and see if we've got any leaks. Looking good. Always the first time for everything. Excellent. So we got back from the bead blasting, just giving it its first coat of primer, inside and out. It's looking pretty good. Got no leaks. What am I using here? I'm using an etching primer. Cleaned it up with some nice soapy water and just a scouring pad. Rough the surface up for the paint, and that's it. We'll just let that dry for half an hour or an hour or so, and then we'll hit it with some industrial top coat. Keep it all nice looking good. Alright, so measuring across from the pan up about 93 millimeters, and square it up 90, about 88, yep, 88 millimeters. We're going to add 6 to that. So it'll be about 94 millimeters. We'll set the oil level at the high level. Put a straight edge across the pan, and then measure up 88, which is about there, plus 6 mil, so that's about the height of where the connecting rod's going to swing. This point here, and we'll go an extra 6 mil down. Well, 7 mil, say 95. So we'll be about 3/4 of an inch above the windage tray. So if we set our oil level at the high point at about there, so we'll set our high mark at 94, 95. By the time we start the engine, the oil level should drop below the windage tray, filling the Accu sump up that we have, and then obviously filling the rest of the engine up, rocker boxes and oil system in the engine. That's yeah, so we'll set the dipstick down 90, 94, 95 millimeters below the pan rail here. That should do us. Again, we just checked the height from the top of the pan rail gasket here to the top or the bottom of the pickup, and then we measured the sump from the pan rail down to the bottom. I think we had 201 4mm from that distance, and we had 211 or 212 mil from that to there. So we've got a good 10-11mm of clearance between the bottom of the pan and the pickup. So that should be enough without causing any restriction for oil to flow into the pickup and into the oil pump. So let's try to wedge this thing in here. In fact, it's not fitting really good at all. It's horrible. Like, that's disgusting. Don't like it. It's not really going to work for me. The dipstick tube's hitting the cap here. It's going in fine. Probably if it goes to this, it's probably going to get to the right depth too. Gonna have to come up with something different there. Back to the drawing board. So we're looking at dipsticks. We've got that one out of the packet. I've trimmed the end up. Even with it all the way in, this is going to be, I don't know where this is going to be. If it turns on the side, it sort of kicks. It's sort of kicking the dipstick sort of left and right. I don't really want it hitting the crank, so the dipstick's got to be orientated sort of out, and I don't know if that's actually going to miss all the exhaust manifolds. So we've ended up making our own little dipstick up. Spun this one up in the lathe, held in by a couple grub screws. So that looks like that'll line up pretty good. And so the high mark here is just at the bottom of the lowest section of the connecting rod bolt, and that should give us enough oil volume to fill up our Sump here, and still give us plenty of volume in the sump for obviously feeding the rest of the engine. Okay, so finally, now that we've got the sump all sorted out, we've got the dipstick organised, we can finally get this sump onto the engine. And around the hoops, front and rear, we'll lay down the one-piece gasket here onto the block, lower down the sump and torque him up. Okay, so we're running a little bit of goodness in here. And on this side, bang some in here. And again on this side. Good little applicator, these things. I've a bugger to get on. It started, but it's fighting me. We've finally got some of the nuts started. Unfortunately, the sump doesn't leave enough room. You know, I have to machine down the edge of these nuts, or just get some plain nuts to go down. It's not too bad. That'll start. But this one here on this corner, and this one on this corner, yeah, they're not going to go on. It's just the way that the sump's made. So I don't have to muck around, and probably just use a standard nut on that one. And same with the back here too. Let me dig a couple up. So there it is. The sump is on. I'm telling you, that was a bit of a mission. I've had to, yeah, basically, these bolts, there's just not enough room. Enough room here to use the this style of nut. These are 1/4, and then here's 5/16, so the nut's bigger. It was hitting the sump. So on all 4 corners, we've just put the normal bolts in, and they've torqued down. The sump's torqued down pretty good, actually. Am I happy with the sump? Yes, I guess I'm happy with the sump. It doesn't fit real good. I guess that's what you get for buying a cheaper sump, I suppose. Righto, time for the cylinder heads. AFA heads they're a pretty good cylinder head. However, where the seats are pushed into the aluminium here, there is a little bit of a lip. Might not be so easy to see, but there is a little bit of a lip on some of these seats. So the seats push down a little bit lower than the aluminium, and well, you know, say 10, 15, 20 thou maybe. So, you know, really this valve's got to lift 15, 20 thou off the seat before it really starts flowing nice into the head. So all I'm doing with the new way is a cutter down on the guide. This is I'm using a 15-degree angle here. So there's a 30 on the bottom and a 15 on the top. Looks like the angles on the seat are 60 or 70, then a 45 and a 30. So what I'm doing, I'm cutting a 15 on top of that and just bringing down the aluminium to the top of that seat. Don't know if you can see that there. That bit I've just cut, and then where I've left off the outside edge of the cutter, where it's left a bit of a groove here, I'll just go back in with I'll put an old valve in here, and we'll go back in with a flapper disc, and we'll just smooth that out. We'll blend that into the bowl, and then we'll move on and do the others. So let's get set up and we'll do one. And of course the battery goes flat last night. I continued anyway with cleaning up the cylinder heads, or that one cylinder head. Didn't turn out too bad. I ended up changing the 15-degree angle that I was initially cutting into the aluminium was a little shallow, so I've changed that and went to a 31 degree. The difference is, well, you can probably see it here anyway. That's the 15 degree. It's quite shallow in comparison to a 30-degree angle. So we're using a 31 degree instead of a 15. And the results were pretty good. Where the airflow is, there's no lip there now, so as soon as that valve opens, we're going to get good airflow in and out of the cylinder head past the valves and the seats. To strip this one down and do the same. This time hopefully the camera won't go flat, and we'll just quickly go through the process to get this sort of finish. I haven't gone with a full polish on these chambers. You can, if you look carefully, you can still see some of the the machining marks. Really, I've just blended that lip that was at the edge of that insert in with this combustion chamber. That's better. Again, pop the 8mm expandable guide in. Same 31 degree angle, spray a little bit of WD-40 on that. We're cutting the aluminium. That just helps stop the aluminium from gouling in the teeth in the cutters. We are just about there. Let's cut down to the top of the seat. So I've cut this angle off the seat there now. It's coming out pretty flat, and then we'll get in with a burr or a barrel roll, and we'll take this edge out and blend it in to the rest of the combustion chamber. It's not bad. Got a couple of old valves here, use them instead of your good valves, obviously. Oops, right hole mark. And with a die grinder, 80 grit cartridge roll. Rough finish. Next up we've got some of these abrasive pads, stand abrasives, threaded bit of spray, these things go a long way. General operation. Do the other three here, and then we might do some port matching. So my first attempt at making a template was sort of, yeah, pretty half-assed actually, not real good. So I'm going to try and get a little bit closer to the cylinder head, and for that we're going to use a little bit of greaseproof paper, and then spray a little bit of soapy water on the cylinder head face. Don't know if this is going to work. So not wetting the baking powder made a big difference. It's not curling up. It's a fiddly club. I think I'll get this matched. We popped the paper right side around. Actually turned out a bit better what I expected, so we'll get some paint, bit of clean up here, but that's pretty close. The center's pretty well the same. Get some paint, we'll mark it up, and then we'll get the die grinder out and port match the manifold to this paper, which will be the same as the cylinder head. So let's give it a go. So again, we've just gone ahead with a marker, pretty well lined up the holes, and then outlined a mark on the cylinder head from the bit of baking paper that we traced from. There's a fair bit here that we need to take out. So the old Adelaide Performer RPMs were this size, and yeah, the new AFR 210s, we've got to take a fair bit more meat out here, which is a good thing, I guess. Get more air in there, more horsepower. So let's get munching. Well, after a couple of hours of milling and grinding, we've got the ports at a reasonable port match, relatively transitioned in. Alrighty, back at the machine shop. Got one of the cylinder heads set up here in the mill. What are we going to use here? A PCD bit? Is this it? Yeah, this is it here. Little. Yeah, polycrystallized diamond bit. Going to put that up here into the cutting wheel and take a lick off of the surface of the head. This head's brand new out of the box, so I've not machined this before. So what we might do is just cover this with some bearing blue and just take a light skim off and see how flat it's come from the manufacturer. Just setting the head up, making sure we got that flat and level, or level and flat, before we start machining.
We're pretty good at side to side
marking. Side to side,
yeah,
fairly flat on zero.
We won't get much better.
Run him down.
But I think we'll be a bit out on the. Oh, I don't know, maybe not. Oh, just face around here. Oh, we're not bad, are we? Yeah, well, no, that's as close as.
Oh, yeah,
we can get a little bit nicer.
3/4 of a tenth.
We can get a nice little out there.
Just touching the deck of the head, or the surface. backing up here in a minute, and then we'll go down a couple of hours and see what we're missing.
I'll just go and see what's going on. I'm going to run through it that.
Yeah.
I don't want to go heavier. Yeah.
It's interesting, look at that, the difference. The head definitely ain't flat from the manufacturer.
Is that bit coming up across?
Yeah, it's coming across here. Nice, it's just touching this edge. So we're pretty good across the, the dial indicator doesn't lie.
Yeah, so we'll run up through it.
On the second head here, it's just touching the center and on the ends. So this area through here is lower. Yeah, get it nice and flat for them MLS gaskets. Second head's coming up pretty good. Low spot here. There and here. First head took about, I think it was smidge over 2 thou to clean up. I'm not sure what this one's going to end up being. Got the heads back from the machine shop and they turned out pretty good. Both of them took just over 2 thou to clean up. We had a couple of low spots in the centres here. But 2 thou is not a great deal. So now, looking at the heads a bit closer, there's a bit of a lip here on the edge. Then I'm just going to grab a barrel roll on all the exhausts and just smooth that lip out there. Okay, so now we're at the point, we've got the heads machined, they've got them all cleaned up. And now we're at the point where we need to check installed height of the springs, so the valve springs, make sure we've got the right installed height, and we need to also check what that installed height pressure is, or seat pressure. And there's a few things that we need to do to check that, and there's a few little tricky tools to use to go about doing it. So let's have a look. So we have our heads obviously disassembled here. We've got all the spring shims under the springs removed. This is like a little micrometer, I guess, you put on the cylinder head. We'll go through this shortly. Put that in there, you put the valve up through, you put your keeper on and you adjust this up. This spins and opens up, and then on the side there is a marker, if I can get this thing to focus. There is a marker there which you can read the height. This starts off at about 1.4 inches in diameter. Length, sorry, and then yeah, it goes out to, well, I think my installed height on these heads is about 1950, so 1 inch 950 thou. So anyway, let's get into that. So a cam card here. I called Carrillo up and asked them what sort of seat pressure and opening pressure I would sort of need to be looking at to spin the thing up to about 7,000 RPM. And they said I need about 250 pounds of valve closed seat pressure and around 700. I don't believe we're going to get to 700 on these springs, and with the amount of lift that I have, 573 and 544. Yeah, I looked at other manufacturers' spring packs, and there's nothing on the market that's going to give me that sort of, I don't think anyway, that's going to give me between 7 and 750 pounds open pressure at that lift. If I had larger lift, yeah, I'd probably get to that that poundage of 7 to 750. But anyway, so what I'm doing is going to try and shim this up without this going into the seal area, so I can at least get around 250, or around there, pretty close to anyway, 240, 250 pounds of seat pressure with the valve closed. So I'll put an additional 15 under here, and we'll just go through the process again. Oh, epileptic. Right. Okay. So it looks like we are 1 inch 912, 910, 912, and take the valve spring and retainer back over to the gauge and see what pressure we've got on the seat. So all I've done is I've set that to exactly what we had for the installed height with a keeper on top, and I've just lowered that down till it touches, and I've put a little black mark here on the shaft, so I'll just stop there. Help me get down to the height without mucking around with the verniers in front and trying to get it the right height. So okay, let's turn her on. Hopefully we get closer to that 250. So we're about 238, 240. So we're close to it. So these heads started off with about 60 thou shim underneath bottom retainer, spring retainer. So now we've got about 130 of spacing under the spring, and that's still just below or just above the point where the valve seal is gonna go, the valve stem seal. We'll recheck all that again, process again. I'll grab the retainer, might help a little. So we're now 1 inch 876 thou. So 1876, 1876, 1 inch 876. Right, set that back to 1876, 18, about there. So we've got that again to 1876, about there. Pop that down. Get the marking stick. Yeah, 248, 250 on the mark. We're actually down a little bit more, about there. So we're about 250, 254 roughly. So we're pretty close to 250 pounds of seat pressure. Now let's work out what the lift's going to be, and how much spring pressure we got at full valve lift. Measure the pressure at 303. Okay, so we're open pressure at 534, and then again at 330, 333. It's just over 500, so 510. So yeah, the inlet will have at fully open. We'll have 535 or 40, and then exhaust at fully open will have around 505, 510. Okay, so we've got the first head done. This is going to be the odd side, so 1 to 7, and then we've checked all the heights and put the shims underneath all the spring spring packs ready for assembly. So the next thing will be to assemble the heads, springs, get all the valves back in. We'll leave these 2 light springs in here, and we'll go over to the engine. We'll just lightly put this cylinder head on top of the engine, and then we'll get a bit of plasticine here, and we'll put that on top of the piston. We'll put a couple lifters in on top of the camshaft, and we'll just sit the head down without the head gasket, and we'll roll the engine over, and we'll measure how much, or no bolts in there either, just sort of sit it on, roll it over, and we'll see how much crush, or how close our piston gets to the valves, heads of the valves. So we'll make sure we've got enough clearance there, and then after that we'll do the next cylinder head, and then we'll bolt them onto the block. Clean up all the seals, pop them babies on first, install these ones. I might have to make a bit of a tool up though, because I think my fingers are going to be relatively sore by the end of fitting all these. So yeah, let's make a tool up. Okay, so yeah, these are a little bit tight to put in with your fingers, so made this up on the lathe. Just a bit of aluminium, and then got an old valve off an LS, cut the head off of it. Yeah, so that should work out pretty good, I think. Yeah, let's give it a crack.
So yep, we've only just touched the plasticine right there, so we've got miles of clearance there, not a problem.
So I've gone ahead and disassembled that cylinder head again, basically to clean up where the threads are punched through into the top of the inlet port runner, taken the burrs out and clean those up, then obviously clean the port out again, put the valves back in, re-greased everything and assembled the valves into the cylinder head with the springs and retainers. The second head, we've done the same thing, and then I've gone along and done the spring heights, and they're already assembled for the engine as well. Before we put them on the engine though, the heads, we'll see what the deck height is, or we'll just have a look at the piston, how far the piston is down in the bore, and we'll take that measurement, and then we might calculate what our compression ratio is going to be, or just confirm what it's going to be. These are the holes for the studs, threaded holes that go into the top of the port. Get the torch in there, you can see the light shining through there. Don't know if I can get this, that one there might help. So inside here, that basically where they've drilled and then threaded run the tap down to put the threads in, they've left just sharp edges there. So when you screw the stud down in there, it's chipping off bits of aluminium, and you don't want that into a freshly built engine. Pistons and bores don't particularly like it too much, so we've just basically pulled the valves out, and like I said, just clean those up so there's no chips or flakes that can fall off and end up into the engine. Got a gauge set up here, mag blocks on the bottom. Just zero it on the piston there. Obviously the piston can rock a bit, and this is dished, so it's obviously you don't want to take the measurement from the dish on the piston, you want to take it from the edge to get our deck height, or our piston down bore. So 0 there, near about 12 roughly. I'll just do the back piston here as well, number 7, set to 0. So it's pretty well smack on 12 as well, which is good. I think I have noticed, so from the back to from the front of the piston to the back of the piston, there is about 1 to 2 thou difference between the front of the piston and the back of the piston. I noticed that with number 1 as well. Interesting. Straight out the box, I'm not going to wash these, put them in any solvent, make sure we've got nothing blocking any of the holes for the oil feed. Just going to wedge them straight in. Falling in under their own steam, that's good, no tight spots. Just using a bit of solvent, 143 here. Give the heads a nice dry up. Make sure there's no gunge on them. Using Chromatic head gaskets for this build. So they recommend no sealant. Away they go, I guess. Looking at that, it doesn't matter too much. Spin it around, let's have another look. Alright. Doesn't look like it matters a lot. The holes are lining up. Come on, down you go. Tight, getting over the dowel. Yep, okay, ready for the head. Let's get the cylinder head installed. Nice and clean. Yep. Next round of bolts, 30 foot-pounds. $50. 60. Says to do them up in 3 increments, but I'm just doing them up in 4 or 5. Not for any particular reason. Stepped up to a bigger torque wrench. Going to 80. This is the final torque setting. Done. Alright guys, well that's it for this one. We've got a bit of a marathon getting the sump all cut up and painted and on the engine. It was a little bit of a difficult thing to get fitted up. You know, some of the holes weren't greatly lined up. Am I happy with it? I think I am. We'll see, I guess, when it's in the car and it's running. And then of course it took a bit of time to get the heads all sorted out with all the spring pressures and spring heights. At least now we've got the heads on, sump on, and that's going to be it for this one. So we're getting closer. I think the next part of the story will be getting all the rocket gear on, all the geometry correct, and we'll set things up on the cylinder heads and measure what the geometry should be, and then we'll look at intake manifolds and exhaust manifolds, whether we need to manufacture anything or fabricate any more up, or we can use what we've got. So until then guys, all gas, no brakes.